Live there. We're recording. We're going live. Okay. You are live.
Oh. We are live.
I'm trying to get the chat.
All right, guys, welcome to Math Monday. Got a little function notation problem there for you. So let's kick this off by doing f of -3.
I don't know where the live chat is for YouTube.
Oh. Ooh, Justin, I don't think I saw what you sent me. There we go. All right, sorry guys, we're trying to get some stuff sorted out on this end with the chat so I can see what you're saying. There we go.
There we go. Have a good show.
Thank you. All right, guys, so we've got some function notation going on right here. I see lots and lots of people going ahead and putting their answers in the chat, which is awesome. All right, so the -3, the -3 just came from, this is just what I'm asking you to solve for f of -3. Okay, so this is what we call function notation. This is where you've got this equation that you're writing because it is a function. So this part here, this x, that is my input. Okay, so that's what I'm putting into my function. Now, this can be whatever you want it to be. It can be an integer, it can be a fraction, it could be a decimal, it could be an irrational number, it could be another variable, it could be a whole expression. Whatever's in there is what you substitute in for the x. Okay, so in this case, when it's f of -3, all that I do is I substitute in that -3 for x, and now I simplify. Okay, so we've got 2 times -3, which is -6. -6 plus 5 equals -1. Okay, now if this were an equation where I were looking at like trying to graph it, okay, for all intents and purposes, f of x is y. Okay, because when you have your x and y chart, you're really talking about that input and output. So f of x is the same thing as y. Okay, when you're talking about like graphing and stuff like that. So in this case, when x is -3, my f of x or my y is -1. So function notation can be really, really handy to deal with lots of different functions that I can do, putting some functions together, combining these things and all of that. But I basically just straight substitute that in, okay? So if I've got, so it doesn't matter what I'm doing here, whatever my input is. So it's still going to be the same thing. I just substitute in for x. Even if this were like 3a. Okay, so f of 3a. So the input is just what's in the parentheses here. So instead of x, I have 3a. So instead of x, I put in 3a. So 2 times 3a is 6a. 6a plus 5, I can't simplify that anymore because they're not like terms. So it's 6a plus 5, that's it. So no matter what you have in your input section, that's what you substitute in for your x value. Okay. All right, so for those of you that are just joining us, I just started off with a little bit of function notation. If there's anything that you have that you're struggling with or you have questions about, so we typically kind of focus on content from pre-algebra to algebra 2. If there's anything in between, any geometry questions that you have, pop them in the chat and I will do my best to get into them, okay? Imugi, sure. A factoring review. Do you mean like factoring quadratics? All right, so factoring quadratics is what we'll get into next. That's fine. So to factor something is to write it as a multiplication problem. Okay, so if I were to say like factor 24, okay, so the factors of 24, I could write that as 1 times 24, 2 times 12, 3 times 8, 4 times 6, and then it just kind of makes a loop around, right? So I would do that. That is called factoring, is instead of 24, I'm writing it as 3 times 8 or 4 times 6. So that is to factor. Now this is really useful when you're solving quadratics or when you're solving polynomials. If you can factor them, then you can solve them much easier. So factoring a quadratic, we're going to start when it's pretty easy. Okay, now let's first talk about where a quadratic comes from. Okay, so a quadratic comes from when you're multiplying, or can come from, when you're multiplying two binomials together. Okay, so when you're multiplying these two binomials together, I'm going to make sure that everybody gets multiplied by everybody else. So a lot of times you hear about like using FOIL to multiply these together. That's just an acronym to just remember to multiply everybody together. So x times x gives me x squared. X times 4 gives me plus 4x. 2 times x gives me plus 2x. And 2 times 4 gives me plus 8. And then I can combine like terms and I get x squared plus 6x plus 8. Okay, now what you may notice, or what, you know, if you've already kind of moved on to factoring, we kind of think about it backwards like this, right? If I were trying, so this is multiplying together. This is factoring. Okay, so what I'm doing is I'm rewriting this expression as a factor, as two things being multiplied together. Okay. Anaya, what grade is this in the USA? So it depends. Most people will see it in probably 8th or 9th grade, or 10th grade. It just kind of depends on when you start getting into quadratics and like into, some people will do it in Algebra 1, some people wait until Algebra 2, but it's somewhere in early high school, I would say. Some people learn it a little bit earlier if they're in like an accelerated program or something like that. So what you notice is that if I were to be working backwards, I've got 4 and 2 here, right? So 4 times 2 gives me 8. 4 plus 2 gives me 6. So we can use that to figure out if we were going kind of the opposite direction, right? We would say, okay, so these two numbers that are in this binomial, they're going to add to this and they're going to multiply to that. Okay, so it's adding to 6, multiplying to 8. So let's take a look at a quadratic from the beginning. So if we've got x squared, we'll start pretty simple, okay? X squared plus 8x plus 15. Okay, so we're going to factor this. This algebra is what we simplify integers into. I'm not sure, books, I'm not sure what you mean by integrate or simplifying integers into. Yeah. So Anaya, it's interesting because the SAT questions, some of them are really, really simple. Like there may be a question like this, like what are the factors of this? And it's a multiple choice. But there are also some really, really hard questions on the SAT as well. And most of them are multiple choice, which makes it even a bit, well, for some of them, it makes it a bit more challenging. Okay, so we're thinking back to what we did. So when we're factoring this, we want to figure out what multiplies to 15 and adds to 8. Okay, what multiplies to 15 and adds to 8. So we think about what are the factors of 15? Well, we've got 1 and 15, and then we have 3 and 5, and then it would start over, right? So 3 plus 5 gives us 8. So 3 times 5 gives us 15. 3 plus 5 gives me 8. So I factor this. This would be factored into x plus 3 times x plus 5. And if I multiplied these back together, okay, I would have x squared, 5x plus 3x gives me 8x, and then 3 times 5 is 15. Okay. So Yards, you can do the x method, but so the x method is where you kind of set it up like this, where you have like 8 on top and then 15 on the bottom, or 15 on top and 8 on the bottom. And then you figure out that this is 3 and 5. But what I have found is with most of my students, you're still doing this. You're still listing out all of the factors to then like find the ones that match up with the 8 and the 10, or the 8 and the 15. Okay. So Yannick, I'm assuming, so can we do a problem resolving around the King's rule? So, and then somebody else was asking for some integrations or some integrals. We don't really get into that kind of upper level, like pre-calc and calculus here. But we mainly stick with like pre-algebra through algebra 2. Okay. So Imugi, you could potentially do this in Desmos. If you understood what it looks like on a graph, which is where when you graph this, it's going to look something like this. It's going to be a parabola like this, and this is going to be -3 and -5. Those would be your solutions. And then that gives you that it's x plus 3 times x plus 5. Okay. So it is applicable in integrals, but that's not really what we kind of get into on this channel. Okay, I can't remember who asked for the factoring review, but let me know if that's enough or if you want to do some more with factoring. No, it's not x minus 3, x minus 5, because these are both positive. So if this one were negative, it would be x minus 3 and x minus 5. What you might be thinking about is if this were a solution, then the solutions would be -3, -5, because you would set them both equal to 0. So my solutions are -3 and -5, but my my binomials would be the +3, +5. Ooh, for money, the vertex. So the vertex for this one would be -b over 2a. So this is where we're finding the vertex if this were a function. Okay, so -b over 2a, that would be -8 over 2. So that's going to be -4. So that means that my axis of symmetry is at -4. So my axis of symmetry is where if I fold that parabola, then where would it it would like mirror, right? So we want to figure out our vertex. So then we do, kind of going back to the top of what we were working on, which is the function notation, because we know that the axis of symmetry, we know the vertex is somewhere along this -4 line. But what I'm going to do now is I'm going to figure out, okay, well, where exactly is that? If I do f of -4, that gives me -4 squared plus 8 times -4 plus 15. Okay, so -4 squared is 16. All right, so I've got -4 squared plus 8 times -4 plus 15, which gives me -1. So f of -4 equals -1. So my vertex, which is sort of like my little turn, the point where it starts going up, okay, my vertex is -4, -1. So that's this point right here. Obviously not drawn to scale, right? It was just a quick sketch. Okay, so -4, -1. And then I can make a little t-chart. I can do x and y where I can do x and y where I'm going to kind of find a couple of points on either side and then just graph those. Okay, let's see. Oh, that's the wrong mouse. Okay, let's see. Let's see here. Okay, earlier, okay, I think it's Gary, distributive property with variables. Okay, so distributive property with variables does have to do with the polynomials and quadratics and everything like that also. Okay. So the distributive property, distributing is where you're multiplying over addition or subtraction. Okay, so if I have A out here and I have B plus C in the parentheses. Okay, so I'm multiplying everything by A. So I'm going to do A times B and A times C. It doesn't change this symbol in the middle because this is positive also. So it's A times B plus A times C. Okay. And then going backwards by taking out that A from both of them, that's factoring again. So if I have something like 2 times x minus 4, I do 2 times x and 2 times negative 4. So that gives me 2x and then 2 times negative 4, which is minus 8. Okay, let's bump it up a little bit. The rule doesn't change. The process is still the same. Okay, but we're going to put a variable out here. And then we're going to put some variables in here too. I'm going to have 2x minus y plus 3. Okay, so again, my rule, the process doesn't change. I'm still going to multiply all the way through because I have x times this everything. So x times 2x gives me 2x squared. X times negative y gives me minus xy. X times positive 3 gives me plus 3x. Okay, so distribution, again, like distribution and factoring are very closely related because if I were to look at all three of these terms and I say factor it, well, I can take out an x for all of them and end up back up here. Okay, so that's distribution over those things. Ooh, so we've got pre-calc summations and chain rule. So we're not really going to get into pre-calc, not going to get into pre-calc and calculus things, but yeah. I need to subtract the negative x. Which negative x? This one? So I don't have any like terms in here. So this is as simplified as it can get because this is x to the 1 power. This is x times y, and then we have 2x squared. So the only things that I could add or subtract together would be if they were the same variable to the same power. So here, these are not like terms because I've got x in this one and then I've got xy in this one. So this is as simplified as it can get. Yeah, so this is as simplified as you can get on it. Okay, let's see. Negative xy is also negative x times y, which can be removed. They are like terms. So you would have to, so the only way that you could do that would be if you could do 2x squared, so you would have minus yx plus 3x. So what you're kind of getting at by like simplifying this together is where you would have to kind of factor this out. So you would do like 2x squared minus, it would be minus y minus 3 times x. That's not really going to be, that's not more simplified. That's getting into kind of like refactoring it. So the question that we were going over, the question that we were going over was just asking about the distribution. So Isaac, if you wanted to tell me a little bit more why you think that this is wrong, that would be great. All right, so yeah, it wouldn't be simplified. It would be becoming more complex. Yeah. Okay, let's see. So Packers, let's see. Can you briefly talk about systems of equations for state testing? Okay, so my big thing for state testing and any like standardized testing and all of that is there's really, it kind of boils down to two main ways, not the only ways, two main ways of solving math problems when they're multiple choice, okay? The first way would be to solve the problem and then find your answer among the choices. The second one would be to use the answer choices to then figure out which one works. So systems of equations really lend themselves to that kind of method. Okay, so let me pull up a system of equations from a standardized test bank that I have. Let's see. Okay, let's see. Okay, so here we go. We've got one. Okay, so we've got this system is 3x plus 4y equals negative 23. And 2y minus x equals negative 19. Okay, so this question here is from the SAT. And it's basically just asking you, like, what's the solution to the system of equations? And they do give you 4 options. So option A is, actually, I'm not going to do parentheses there because that might get a little messy. All right, so -5, -2. B is 3, -8. C is 4, -6. And D is 9, -6. All right, so this is an SAT question from like a released or practice test thing. Okay. So this one right here, so when it's multiple choice, okay, this gets into the thing where you've got 2 options, right? Number 1 is to solve the system and then find your answer among here. The other option is to use these answers and plug them in to see which ones work. Okay, so for this one, it's kind of a mess. It doesn't really lend itself to elimination because, first of all, I would have to flip the order, right? And then I would need to multiply one of them by a number to then cancel out one of the variables. I could do it with substitution, right? I would probably do solving this one for x, and I could substitute it in up here, okay? But what I can also do is I can just plug in my numbers and put it in, okay? So let's solve it with substitution, okay? So solving with substitution means that I need to solve one of these for one of the variables, okay? Well, actually, you know what? I'm going to give you a couple minutes to see what answer you would get. Remember, you can either solve the system and find your answer among the choices, or use the choices to plug them in and get them on here. And somebody earlier was asking for an SAT question. This is SAT. Okay, so some people are saying A, some people are saying B. Should figure out how to do like live polls or something. It'd be kind of fun. And we could see like what everybody's voting for. More people saying B. I don't know if anybody on YouTube is watching and listening. There are some people watching over on YouTube. Go ahead and put your answer choice. Okay. All right, guys, lock your answers in. All right, so first, all right, let's see. All right, seems like everybody's starting to think it's B. Okay. All right, so remember when you're solving a system of equations, that means that the solution is the same for both of them, okay? That means that the x and y values in both of these are going to be equal, okay? So to solve this, if I've got, like, I can set them equal to the same thing and stuff like that, or I can plug in these points, but keep in mind that just because it works for one of them doesn't mean it necessarily works for both of them, right? So you've got to make sure that you are trying this point or trying this solution in both of them. All right, so if we, well, let's go ahead, you know what, actually, let's start with just kind of plugging them in and seeing if they work. And let's just focus on A and B because everybody seems to be pretty well settled that it's not C or D. Okay, so A is -5, -2. So that would be 3 times -5 plus 4 times -2. And we're going to say, does that equal -23? So I put the little question mark over the equal sign because we're saying, does it equal 23? 3 times -5 is -15. 4 times -2 is -8. Does that equal -23? Yes, it does. Okay. So A works for the first one, but I've got to make sure that it also works for the second one. And when you're doing this on a standardized test, you can just be plugging it into your calculator. Okay. All right. Now be careful with this because it's 2y minus x. So that means that it's 2 times -2 minus -5. And we're saying, does that equal negative 19? So 2 times negative 2 is negative 4. Minus negative 5 is the same thing as plus 5. That does not equal negative 19. So A does not work. Okay. So now let's check out option B. So option B is 3 and negative 8. So I start out with 3 times 3 plus 4 times negative 8. I'm saying, does that equal negative 23? 3 times 3 is 9. 4 times negative 8 is negative 32. Does that equal negative 23? Yes, it does. Check. All right, so now let's check to make sure that it fits with the other one also. So we do, remember switch the y and the x. So 2 times negative 8 minus 3, and we're saying, does that equal negative 19? So let's see, negative 16 minus 3 equals negative 19. Yes, it does. So my solution is B. Now, if you are feeling super confident in this, like this is just kind of getting into test taking strategy. If you're feeling really confident in this answer, you're done. You don't have to keep going. Okay, but if you're just plugging these into your calculator, just double check the other two. If you're being pretty efficient with it, just check the other two just to make sure you didn't make a misstep or a miscalculation, okay? So that's one option where we're just plugging in the answer choices and figuring out which one works. The other option is to actually solve this system. So let's go over solving systems. Okay, like we said, there are a few different ways to solve systems of equations, right? One of those ways is elimination, and the other or another way is through substitution. So I'm going to work on this through substitution. Okay, so I'm just going to rewrite, because I don't want to rewrite all of the answer choices. 2y minus x equals negative 19. Okay, so now we're just going over solving this system. Okay. All right. So like I said, elimination, it's not really set up very well for elimination, so I'm just going to go with substitution. So to go with substitution, I need to make sure that I solve one of the equations for one of the variables. So then I can substitute it into the other equation and solve for the other variable. So I'm going to start with this one. So 2y minus x. So I'm going to subtract 2y from both sides. So I have negative x equals negative 2y minus 19. I'm going to flip all of my signs. So I get x equals 2y plus 19. Now, since I know that in a system of equations, the x and the y are the same value, if x equals 2y plus 19 and 3x plus 4y equals negative 23, I can substitute this in for that x. And that's what I'm going to do. So now I've got 3 times 2y plus 19 plus 4y equals negative 23. And going back to what we were talking about before with distribution, right? Coming back up, it's all full circle. It never goes away, right? Math is something that just keeps building and building and building. So I'll distribute the 3 and get 6y plus, let's see, 19 times 3 is 57. Plus 4y equals negative 23. Combine the y's, so I get 10y plus 57 is negative 23. Negative 23 minus 57 is, so I've got 10y equals negative 80, so y equals negative 8. Now, once I have this value, I can go back up here And I can substitute it in for that y there. Okay, so now I know that y is -8. So 2 times -8 minus x equals -19. I'm going to kind of slip this up here. -16 minus x equals -19. Add 16, so I get -x equals -3. So x equals +3. So my solution to this is 3, -8. So if I go back up to my answer choices, it's 3, -8. So two different ways of figuring out this same problem. So again, you can use these to just plug in and figure out what it is, or you can actually solve the system and find the answer in your choices. And those two strategies really work for the vast majority of problems on standardized tests. I mean, you know the answer is one of those choices, except when they put that like not enough information or none of the above. Oh, that always got me every single time. It's so tricky because you kind of go, yeah, it could be none of the above, right? You can talk yourself into anything, really. All right, but those two major test-taking strategies I have found to be really helpful, that you're either going to plug in your answers to the equation and figure out which one works, or you're going to solve the equation and find your answer among the choices. Hopefully it's there, right? Okay, so let's see if I missed any. Did I miss any questions about the content? Okay. No, everybody's still doing that. Okay. The mixed method of substitute and eliminate. Ah, okay. Kind of do a little bit of both. Yeah, there are lots of different ways to solve systems of equations. And you can even solve like linear and nonlinear systems of equations. You can have, you know, a parabola or a quadratic or like a quartic line, and then you also have, you know, you also have a linear equation or something like that. Okay, so let's do this problem here. So let's go back to function notation. So let's do f of x equals 10x minus 5x squared. And what I want you all to find is f of x plus 1. Okay, so when we've got this, remember it's going back to that function notation that we talked about at the very top of the hour. And we're going to figure it out here. Okay, so Song Guru, you substitute and then simplify. So go ahead and so we substitute and then we simplify with these. Mm-hmm. thank you for all the hearts and the love. Keep them coming, guys. Keep sharing the live. Keep spreading math love. And if you have any questions or any content that you would like me to go over, maybe you have a quiz or a test coming up this week, just put it in the chat and we can get into it. We can go over it. We got about 15 minutes left that we'll be here. Oh, nice, Lejeune. I'm glad. That's exciting that he's watching. Hi, 7-year-old. Well, Carlo, I want to make sure that everybody has a chance to work it out. What's your answer for it? Thank you. All right, are we ready? Okay. So the way that we use function notation again is when you've got this, whatever's in here substitutes in for the x. Okay, this is my input. So my input is x plus 1. So that is what I'm going to substitute. Instead of x, I'm doing x plus 1. So this is 10 times x plus 1 minus 5 times x plus 1 squared. Okay. So now this is the substitution, but after we substitute, we've got to simplify. So I'm going to distribute that 10, and that gives me 10x plus 10. Now over here, I'm actually going to leave that minus 5 for now because I'm going to expand this for a minute, x plus 1 times x plus 1. So x plus 1 times x plus 1, I'm going to go ahead and I'm going to put those together. I'm going to multiply those together. That gives me x squared. Let's see, plus x, so that's plus 2x plus 1, and I've still got that minus 5 out here, and this 10x plus 10. Okay, so I'm just working through these step by step. Okay, and I have a feeling that a lot of this stuff is going to cancel out, actually. Okay, so now I'm going to distribute this 5, but it's not just a 5, it's a negative 5. So I'm going to distribute that negative 5. Now, nothing has happened to my 10x plus 10 up here. Minus 5 times x squared is minus 5x squared. Minus 5 times 2x gives me minus 10x. Minus 5 times 1 gives me minus 5. Now, I look for like terms. Okay, so I only have one set of x squared, so that one's going to go first. So I've got negative 5x squared. Now for my x's, I've got a 10x and then I've got a minus 10x. Those actually cancel each other out. And then I'm left with 10 minus 5, which is going to give me plus 5. Okay, so I've got negative 5x squared plus 5. That would be my simplest form. Okay, now could I factor out a negative 5? Yes. Could I write it in a couple different ways? Yes. But this, when you're going through and you're doing these, this function notation and substitution and simplifying and all of that, this would be your simplest form, is negative 5x squared plus 5. Okay. So this is technically standard form. which is where you go with like the highest degree to the lowest degree. So this one is x squared, that's the second degree, right? And then that plus 5, it doesn't have an x. Well, it's x to the power of 0, but so that's why you would list it with the x squared first. Okay, and then if we wanted to factor this, we could do -5. Oh my gosh, and then it's a perfect cube. Or it's not a perfect cube, it's a perfect square. Yeah. That's exciting. Yeah, actually, let's talk about that. This lended itself perfectly. Okay. Right, so f of x isn't in that form, but it was just how it was given to us. Okay, so this problem here, if I were asked to solve this, if I were asked to solve this quadratic, okay, what I can do is, there's a lot of stuff I can do, but what I'm going to do is I am going to, well, actually, you know what? I'm going to leave it up there for a couple of minutes and see if you guys, see if you all come up with the answers for this, okay? So solve this quadratic. I know we're kind of jumping around between like pre-algebra and algebra 2, but let's give this a try. Yep, keep sharing the live, keep sharing all that stuff. Oh, hey, Lindsay. We're just getting into some quadratics. Okay, so go ahead and put your answers into the chat so I can see them. Yeah, let's just work with real numbers for this one. I mean, there aren't any imaginary solutions for this one. Oh, yeah, some people are getting it right. All right, so when I'm looking at this one, I'm dividing it by -5. Okay, you can also kind of think of it as like factoring out that -5, but since it's a solution, or since it's set equal to 0, I can just divide both sides by -5 because this is just going to stay as 0. So this cancels out and this becomes a -1. So now I'm looking at x squared minus 1 equals 0. So this setup right here, this x squared minus 1 equals 0. This is called a difference of squares. Okay, it's kind of a special binomial. It's a special thing that you might recognize. Okay, so what this is, but what I can also do is actually I could solve this if I add 1 to both sides, and then I've got x squared equals 1. And then I can take the square root of both sides. And I get that x equals plus or minus the square root of 1, which is 1. So my solutions for this are -1 and +1. Those are my solutions. Okay. Now the difference of squares, if you see something like this, right, x squared minus 1, I can also factor this as x plus 1 and x minus 1. And then if I set those equal to 0, then that's going to give me my plus and minus 1. Okay. So Damien, we don't really get into integrals on this channel. We tend to stay more kind of like pre-algebra into algebra 2 a little bit more. But if you have a specific question about integrals, we have a great community in our chat, and so you can, put your question in, and somebody may be able to help you out with that. All right, let's do all right, should we do some trig? Let's do some trig. Let's do some law of sines and law of cosines. Let's do that. Okay. So here we've got a triangle. This is 75 degrees. And we'll do 13 and we'll do 17. We're going to find x. Okay. Ooh, Lindsay, what do you want to do about radicals? Okay, so here we go. We've got some, okay, Lindsay, we'll get into that in a minute. Yep. So this is, we've got a non-right triangle. Okay, so we've got this 75 degrees, we've got 13 and 17, and we're trying to find this missing side. Okay, so this is, ooh, yeah, so saying this is the law of cosines. Okay, so the law of cosines and the law of sines are what you use when you have non-right triangles. Okay, so we cannot use Pythagorean theorem on this because it's not a right triangle. Okay, so Pythagorean theorem only works if it's a right triangle that you're working with, and it's not. Okay. So when you set this up, since we have this 75 degrees here, and then that x is the opposite side from that angle. Okay, so we're going to use law of cosines, which says that x squared is going to be the sum of the squares of the two sides. So 13 squared plus 17 squared minus 2 times the other two sides, and then times cosine of 75. So that is the law of cosines. So trig, one thing that I keep emphasizing with my students is that trig is really, really, really repetitive. You're kind of doing the same thing over and over and over. You're doing the trig ratios, you're doing law of sines, you're doing law of cosines. It's just a question of knowing what to use and when, right? Or when to use and what to use, right? All of those things are kind of they go hand in hand. So with trig, once you sort of get over the hurdle of like, oh, it's just the same thing over and over, then you're going to be set, right? So I've got, let's see, so 13 squared plus 17 squared is 458. So I've got x squared equals 458 minus 2 times 13 times 17, which is 442, cosine 75. So x is going to be the square root of that whole thing. So 458 minus 442 cosine 75. You can write this, or you can type this into your calculator as it is. Okay, you can type this in right as it is. Do not fall into the trap of saying, oh, well, then it's 16 cosine 75. No, it's not. It's 458 minus 442 times cosine 75. It's not 458 minus 442. Okay, so it's not 16. We do square root of 458 minus 442 cosine 75. Enter. And we get 18.5-ish. Okay, I always tell my students to round to the nearest tenths for side lengths, so 18.5 is what we're calling it. Okay. Okay, so Lindsay asked to go over simplifying radicals, which is something that I know a lot of you probably struggle with, right? So, God, I'm struggling with picking up that board. Okay. So simplifying radicals. If you don't have a calculator like this NumWorks one that simplifies them for you, it's a beautiful, beautiful thing. Get yours now. Click the link and do the stuff to find out how you can get yours at a discount. Or if you are a math teacher out there, you can get one for free. You just have to go to the website. It's just numworks.com. I love my NumWorks calculator. It simplifies the radicals for you. That's the biggest selling point, I think. There's a lot of other really perfect things, like you don't have to use a separate negative as opposed to subtraction. It's the same button. You can just type in like, find me the zero, find me the maximum, find me the minimum. It's a great calculator. Anyway, all right, so simplifying radicals. So let's think about something like square root of 24. Okay, so the square root of 24 is not a perfect square. Oh, my calculator, it is NumWorks. NumWorks. It's a great calculator. It's amazing. I wish they came in other colors, actually. I think that would be kind of fun to have different colors of NumWorks calculators. I'll have to let them know. Okay, so square root of 24. This is where we are simplifying the radicals. So we are not rounding, right? We are finding the exact value. The exact value of square root 24 is not rounded, okay? We're going to simplify it kind of like a fraction, right? Just like 1/3 is not 0.3, right? 2/6 is not 0.3. It's 1/3. Okay, so when we look at these radicals, what we want to do is we simplify them by taking the square root of anything that we can. And it all goes back to factoring. My goodness, all night tonight has been factoring stuff, huh? Okay, so when I look at this, I think about, okay, well, which perfect squares are multiplied within square root of, or within 24? So I know that 24 is 4 times 6. So I know that 4 is a perfect square. So that 4 is going to come out from the square root, from the radical, and it's going to become 2, and that goes away. So 2 is out, and what I'm left behind with is 6. So this is 2 root 6. That is my simplified radical. Okay. All right. So let's look at one that's a little more complicated. Okay, let's look at square root 192. Now, oftentimes teachers will have you do this without a calculator. Okay, they'll say you're not allowed to use a calculator. Okay, square root of 192. Okay. Okay, Lindsay, we'll get to the fraction part. Okay, so square root of 192. Well, I know it's divisible by 2, and I'm going to see if it's divisible by 4, right? So 192 divided by 4. I'm going back to old school long division, so that's 4, so that's 16, so that's 32, so that's 8. Okay, so that's 48. So 192 I know is 4 times 48. So I can go ahead and I can take this 4 out. It becomes 2. That goes away. So now I'm looking at 2 root 48. But 48 I know is also 4 times 12. Okay, so then let's do that. So I've still got 2 root 4 times 12. The 4 comes out and it's another 2. goes away. So now I've got 2 times 2 root 12. So that's going to give me 4 root 12. But 12 is 4 times 3. So I can do it again, right? So 12 is 4 times 3. So I've got 4 root 4 times 3, right? The 4 comes out, becomes a 2. Got 2 times 4 root 3, so that's 8 root 3. And now I don't have any more perfect squares in there. So this is my simplified version, is 8 root 3. Okay. So we might be able to get to that, but I'm going to do one more thing with the radicals when it's in a fraction. Okay. All right. So when you have a radical in a fraction, what I have a feeling that you are getting at, Lindsay, is rationalizing the denominator, which is an obsolete thing that we still have everybody do because that's how all the textbooks were written. You do not need to rationalize the denominator with the calculators that we have today, but we do it anyway. Don't ask me why. Okay, so if I have square root of 9 over 4, okay, just bear with me. So square root of 9 over 4 is going to be the same thing as square root of 9 over square root of 4. So that gives me 3 over 2. Done. Right? A little more complicated if they're not both perfect squares. Okay. What if it's square root of 9 over 5? It's still going to be the same thing as square root of 9 over square root of 5. Square root of 9 becomes 3. Root 5 stays root 5. Okay. But gasp, there's a square root in the bottom. It doesn't really matter. It does, but it doesn't. Okay. Your textbook, the SAT, the ACT, standardized test, they're all going to want you to rationalize this denominator, which means we cannot have that root in the bottom. Okay. So if you're looking for this answer on a standardized test, it's not going to be there. Okay. What will be there is something a little bit different, because what you need to do now is you would multiply by a version of 1 that's going to get rid of that root 5. And that is root 5 over root 5. Because a root, so rationalize means that it's making this bottom number into a rational number. Because right now, square root 5 is an irrational number. It's not rational. Okay. But if I multiply it by the same root, now I've got 3 root 5 over 5, because square root 5 times square root 5 is 5. And this is the answer that would show up in your answer key. This is the answer that's going to show up in your textbook. All right, those are the answers that are going to be there. Okay, so you're just changing it into a rational number. So that's where we are. Okay, so sometimes, well, most of the time you're going to have to rationalize the denominator. There's not really another way to simplify it. I mean, so the other thing is that, like, if this were like a 10, so it was 10 root 5 over 5, I could simplify that 10 of that 5, so it would be 2 root 5. But there's not really any other way to simplify it. Let's see, what age is this? So usually this is, I mean, some kids will learn it when they first learn about square roots in middle school. Rui, sorry, I can't read the name. Why do we have to rationalize? But they make us do it anyway. So back in the day, before, I have to always tell my kids, this is even before I was in high school. I guess when you were using a calculator, you couldn't put that root on the bottom. You couldn't calculate that. So you had to do this to then figure out what the actual number was. Because the calculators they were using are like the slide rule or the log tables or whatever, couldn't do this calculation if the root was on the bottom. That's all I know about it. And now I just tell my students to do it because they're not going to see 3 over root 5 as an answer choice. They're going to see 3 root 5 over 5. So understanding that that's where it's coming from, that's the only real reason why I tell my students about rationalizing the denominator, because you can still do it on your calculator that you have right now. All right. Ooh. Okay, so somebody asked, oh, toy bits. So conjugate numbers, they are very closely related to this because it's a way of like multiplying by something that's going to rationalize it. It's going to make it into a rational number, okay? So this will often come up in when you're dealing with imaginary numbers. But really, but let's start with the roots, because imaginary numbers, you're going to treat it the same way. So if I have something like 5 over 3 minus square root 2. Okay. So remember the problem, right? The problem is you've got a root in the bottom. Okay? So what we need to do is we need to rationalize it, right? We need to multiply, but if I just multiply it by root 2, then I'm going to have 3 root 2 minus 2. It doesn't help anything, right? So what you do is you talk about the conjugate numbers. So the conjugate number is something that you're going to multiply by to get rid of that radical. Now in this case, we use something we talked about earlier again, which is the difference in squares. So I'm going to multiply this by still a version of 1, right? Any version of 1 or anything over itself is 1, right? So I would do 3 plus root 2 on the top and the bottom. 3 plus root 2. So what that's going to do is then I've got these two like binomials that I'm multiplying by. So 3 times 3 is 9. So I'm going to kind of put this, well, what we've got on the top is we've got 5 times 3 plus root 2, right? I'm just going to go ahead and write that in. Okay. Now on the bottom, I'm going to do 3 times 3, which is 9. 3 times positive root 2, which is plus 3 root 2. 3 times negative root 2, which is minus 3 root 2. You might see where this is going. Negative root 2 times positive root 2 gives me negative 2. That 3 root 2 and that negative 3 root 2, they cancel out. Yep, it's exactly the same. It's just you flip the sign. So now I've got 9 minus 2 on the bottom. So I could distribute the 5 and get 15 plus 5 root 2 over 7. So again, our calculators I can do my calculation just like this. 5 divided by 3 minus root 2. And it tells me what it is, okay? It tells me that it's 3.153009, blah, 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 blah. It's not a problem now. But here's the thing, is that if you go through and you solve this whole problem on the SAT or the AP or something like that, and you are looking for this answer right here, this 5 over 3 minus root 2, it won't be there. It won't be there, okay? The answer won't be there because they expect you to conjugate that and rationalize that denominator, this is what's going to be there. So this is the correct answer. This is not the correct answer. They're both technically correct, but still. But also the NumWorks calculator does it for you. So there's that too. Let's see. I do have a YouTube channel. Same. Yeah, Eric, I've got a YouTube channel. You can take a look over there. All right. So I know there's a lot of people in here now, but it has been over an hour that I've been working and doing this, and it has been a full day of school on top of that, and a Monday. We are so close to spring break. But this weekend, I'm going to be heading to the Math Teacher Conference. So hopefully next week, maybe we'll be coming to you live from the National Council for Teachers of Mathematics Conference. Okay, so if anybody out there is a math teacher, come find me at NCTM. I would love to meet some of you. All right, guys, have a great night. And I'll see you next time. Bye.